Hello and welcome back to Compiler Programming. In the last video, we finally managed to make our executable work and also did some cleanup of the sections of that executable. And finally, we did this setup so that we don't really have any more hard-coded things in our imports, but the imports themselves like we don't have any hard-coded offsets, but we still have the imports themselves being hard-coded. So one thing I want to do now is to move some of this stuff around such that we can do less of the patching around. So in particular, ideally, I would like to get rid of this stuff. While one of them will be quite easy to change, namely this one, I believe. Yeah, this one should be relatively straightforward to change, but this is a bit trickier one. And the reason this is a bit trickier is because what we have in here actually affects the bytes that we need to put into this call. So that's another thing I can try to figure out now. Maybe actually that's what we will start with. So our job right now would be to try to come up with this, actually these 4 bytes in such a way that we don't have to recode them, because this instruction, if I open Firefox and open our x86 instruction manual, so what we have here, I believe at least, is this one, call RM64. And the reason it's T15 is because of how the address is encoded, but the actual address is this location. So this is a REP relative encoding of an address. At least that's my understanding of what that is. Okay, if that's the case, these last 4 bytes are relative offset, and we can try to come up with a way to correctly calculate them. Okay, that would be what? Well, we need an address to patch, so we say S32 star relative exit process REP relative address, and then I do buffer allocate exe buffer and S32. And now we need to figure out what to put there. If we do it right now, we should get this number if we don't move this location anywhere. And the way we come up with this number is we need to actually have a RVA of this address as well. So let me move this define a bit up. And but RVA is calculated after the instruction, so we first allocate this stuff and then we calculate the RVA. So we say ExitProcess call RVA is a file offset to RVA, and we need to pass a text section header. I believe that's how it works. Yeah. Okay. So we know the relative virtual address after this instruction. We also know the relative virtual address over here, and that means that we can actually try to calculate this difference. and put it into here. The way we do that is, so we have now this offset. Let's try to do. So we say ExitProcess rip relative address. We need to patch into there. And this is equals to ExitProcess. So IAT REA minus ExitProcess REA. Okay. And we can actually assert that this stuff is 0x. I need to turn this around in my head. So yeah, f1, 0, f. I think that is correct. I need to turn it around. Yeah, I think I do. 0 f f1. Where's my calculator? Hex 0 f f1. And this is, no, this is too big. How's it before? F1, no, this is definitely too much. Okay, I'm a bit confused right now. Let me just check this. So this is supposed to be something like 997. So if I remove this stuff, say 997, turn it into hex, that will be 35E. That is kind of not what I expected. Let me look at this in the debugger first, and then we can continue with this stuff. So this should still build and this should still work. Our test stuff. Okay, tests still pass. Let's open this in devenv and look at the actual offset, because I think we looked at it before and it's supposed to be around 900 bytes, because our code starts at location 10,000 and we have, yeah, it's kind of really bad that it doesn't show the raw instruction here. But yeah, a bit slow today. So the difference is also in hex. So in reality, it will be, 997 hex, and that's fine. So we want to know what is going to be something like 0 f1, 0 f. Let's do f1, 0 f. That's fine. But this is definitely more than what we want. So this 0, 1 f or 0 f f1, 0 f f1. That looks okay, because 1000 in hex is 496 and we have here 481. This is what we expect. So yeah, it should be 0xff1. This is what we expect to be here. Now we can revert this and see if my expectation is matching. We have Visual Studio, which probably doesn't allow to build this, yeah. Okay. It legal indirection, illegal use, sounds amazing. Undeclared identifier. Okay. Yeah, just one missing semicolon and we have a bunch of problems. So here it actually is supposed to be S32. And here we need equals. Good. Let's check if that works. Okay, it still does. So that means for us now that we will need to figure out something like this in our assembly encoding once we start to integrate all of this stuff together. But for now, we can get rid of another hard-coded number, and that also means that we can start to move things around as much as we want to. Let's rerun the tests, add it to index, so we have a save point, and we can start to do different things. So we have this import directory over here, and it points to two lists. It points to the list of it points to a list of things that will be later replaced by addresses, and it also at the same time points to another list, which is a list of names. And this one, this first thunk is something that will be later replaced by addresses, right? So this is actually the location that we use in our call procedures for encoding. And this one, I believe, just points to a place that then points to another list that is contains pointers to this thing, but this stuff as well also contains pointers to the same. I think I will bring up this thing again because it sort of shows what I mean, but still takes a bit of time to get used to it. So as you see, there is some library stuff. In our case, this is kernel. And then there are two places that both point to this stuff. So if we wanted to rearrange this encoding in such a way that we have to do as little patching as possible, it would stand to reason that we should start with these things and then sort of construct everything else in reverse. And we can do that. Let's take this out and start and try to put it at the very start of the IET. Okay. What do we need to change now? We have import name RVE. Well, that's fine. But now we will need to actually move it up, and what we previously called this exit process name RV, we will just do buffer right. So let's remark this so I don't miss this. But the idea now would be that we move this out over here. We take this, we rename it to be exit process name RVA. And we also need to update this image thunk. So this is another thing that needs to be marked. And finally, So let's do it this way. We get the hint, we put the function name, then we write it aligned. That sounds good to me. And here instead what we do is we just do buffer append I think we want to append U64 or two S32s. Yeah, I guess we want to append two S32s. One of them is always 0. Let's add a comment. Needs to be 64-bit value to hold a pointer to the function that will be resolved by the system when loading the executable, but RVA is only 32 bits, only S32. So we output second 0 S32. And this was actually wrong previously, because if our number is negative, and I think it will be now because we will be pointing back in memory, we will end up in a situation where the first bit will be wrong if we just output it as S64. So we do need to keep it as S32, I think, but I'll put there. But maybe I'm also wrong. We'll figure out if the system crashes or if it works correctly. But at least I have a comment here to think about it. So this is 0, and this is exit process name RVA. Okay. Let's try this out. Then this 0 is end of IAT list. So every function will be an entry here, but at the end of it we always write 0 to let the loader know when this ends. Okay. And yeah, here is another place where I needed to patch it, I think. Yeah, we took image thunk and then this is the same situation, so maybe it is okay if it is negative. So let's start like this, and then we'll see if that is actually correct. Okay. I'm missing the buffer argument. That is fine. We can put this. Maybe it would make sense to add a macro that just implicitly writes to the buffer, so it is easier to deal with this kind of stuff. But it's also okay as it is. Let's check if I'm correct or I messed something up and continue from there. Just a second. So yeah, this should be fine. Let's try to test. Okay, it is still fine. Let's recheck. I will open actually Fileizer, and what I want to look at if it still can recognize the imports, and it doesn't seem to be able to, which is very, very interesting. But the code still works. Okay, what about Pepper? I want to look at what the thing actually ends up looking like. Section headers, text, our data. So yeah, if you notice, the number here changed. Previously it was, what's it, 1F something, and now it's larger because the thing moved in the executable. If we look at our data, then first we have this ordinal stuff and exit process, and only then we have this stuff, which actually is probably wrong. So why does our code work? Actually no, it's not wrong. Yeah, it is this stuff. So yeah, that's correct. And in reality, we don't need this whole S64 dense. It should be U64 here, and here also U64, and here like this. And these things are always positive. So I was wrong. This thing is U34. Like, it cannot end up being negative because we go from the start. Yeah. Sometimes, you end up thinking the wrong things. So let's fix that. Remove that comment and take this and put it over here and do it like this. Okay. It's interesting that it was able to build with this thing open, but okay. Okay. Good. So the tests are still passing. We can open this again and look at it in more details. But it doesn't really change anything. We still have 2000 here. Good. But the point of all of this, again, was that now we know the relative virtual address of our strings before we actually use it for any other calculations. And that is really, really helpful. And we will still have this stuff for this usage here, but my hope is that we can switch the sections as well. So we will put our data segment first and code segment after it to help with this. Now, the problem with this stuff will be that all of our offsets will be negative, but I think since we have to use 32-bit offsets for heap relative addressing anyway, I think that actually doesn't change any efficiency in encoding, and it will just help us keep saner in the long run. I will add a to-do here explaining just that try to flip or change places, or try to put our data section before the text section to avoid this patch. And I think if we structure everything carefully, we should be able to almost completely eliminate patching. The only place where you will still have to do is in the code itself, where if you have like mutually recursive functions, you will end up with like negative offsets and patching. But overall, I think that should not be an issue, for at least for the main layout of the executable. And that's just very helpful because these patches are finicky, and as soon as we move to dynamic buffers, we'll have to replace, like you can't use pointers anymore, you will have to use offsets into a buffer, because if your buffer is relocated, your pointer is invalidated and stuff like this. So If you can avoid the patching, you should try to avoid the patching. It's just better long term. Okay, let's see if we do anything else where we have to patch. I mean, this is not great, even though we don't really patch here, we still end up in a situation where we first allocate the import descriptor and then we output this image chunks. So let's try to move this around and put this over here and put these two over here. And now nothing should really change, so I don't think we need to even touch the code. But what does change is we have a separate path where we have these thunks. So that builds. Let's see if it still works. It does still work. Just a reminder, who haven't watched the previous episode, what we are looking for is exit code 42, because this is what our executable is doing, and the way you can see that is with this B9 to A. So this is number 42 in hex, and this is like move RCX 42. This is the instruction. And here I call ExitProcess. I think maybe dollar in actual assembly syntax, but doesn't matter. This is our code. Cool, so this worked when I moved it up there, but probably I want to move more things around, because I want to move it over to, let me think about it. Yeah, we can probably move it over here. And the reason I want to do that is I want to have, like, if you think about it, this will eventually be a loop that just goes through all of the functions that we want to import. And this is exactly the same loop. So we again go through all of the functions that we want to import. And it would be just nicer if we can do this together. Okay. So this is fine. And yeah, that's good. Let's check it. Still works. And one more thing is I want to move this library name even more up, because where is it used? Yeah, it's used in this import descriptor, and these ones probably also need to be a zero terminated list. Yeah, I guess we also need zeros here, so I'm actually doing it wrong, where now I also need to say buffer allocate these, and I will need to write a 0 there. So let's do this while we remember, and say end of image list. Let's try it out. Okay, still works. At least it doesn't break. And the reason I think it wasn't breaking before is because we have a bunch of zeros at the end of the file anyway, and this was the last thing that we were putting there, so it wasn't really a problem. But I think we have to do this. Okay. So library name, this is part of this stuff. So I guess it is okay if it is right before its directory. Cool. So let's add this stuff to the index. So we have a save point. And the next thing would be, I want to start using a structure like that. And as far as functions go, it probably needs to be an array of something else than just the name, because we will need, essentially we need a mapping from a name to relative virtual address that we will use when going through it here. But that can probably wait. So let's try this. We have this import setup, and say Kernel32. So this is the stuff that we need to change as far as the name goes. So Kernel32 library name is the library name, right? And I guess we do need this stuff. So let's create a type dev. So type dev name dev struct name to RVA. Yeah, name to RVA. That's fine. Or import name. Okay, that's good. So we have const char star name, and then we have S32, or actually U32 RVA. And initially these things will be 0. And once we figure out where they are, we just put this in. So we have this list of imports, and functions will be now a list of these things. We have name is ExitProcess, and we have RVA that is 0. Maybe we should put something else besides 0. Yeah, let's put cafe beef or something. Just some recognizable string, but it will be flipped around in bits, so maybe whatever. Let's just put C's in here. Just something that we can see in the hex dump if we mess up with this stuff. Okay, so this is the functions. Now we need to change it to be this. Okay, and its own name will be this stuff. Yeah. We call it a library. Or we can even call it DLL. Okay, and that DLL is the same thing. We put name and we put RVA. Good. So we say Kernel32.dll, which is pretty nice because that's exactly what it is. RVA is file offset like that. Okay. Now I can do basically the same thing as we were doing before. Let me keep it here just for the reference. And I say Kernel32 DLL name. Okay, align name size. We don't have library name. Instead of we have this one. And instead of static array size, we can do stir len of this plus 1, I guess. That sounds good. Maybe we can keep this around for now, and we just use this Kernel32 DLL RVA. Yes. Previously it was name RVA, now it's like this. Okay. Let's see if I messed this up. And I did. Kernel32 DLL was not found. That's interesting. So let's try to figure out what we have there. Test, data, section headers, our data. Yep. So this is not great. Okay. Yeah, it uses static array size. So we need to say 32 name size is this. Okay. Should be something like this. Okay, this is size t. Okay, fine. Let's try this again. Cool. So we got rid of the hard-coded Kernel32 library name. That's always a good thing. So we can remove this stuff. And now, okay, before we can actually do something about this import directory, we need to also update all of the functions. And there will be two things that we need to put in there. So one is the let me think for a second. So we have this list and we have this list. This one points to this one and this one points to this one. So actually it is not even about the so it's not about the names here, it is about just the first one in the list. So I guess we will need to put it onto here and say something like IIT RVA is this stuff, and then what else? It will be which thunk RVA is this. Okay, so let's try to do that. So now we say Kernel32 IIT RVA and just let's see what breaks, because it will tell us where it's used. Okay, this one is yeah, there are multiple to-dos here, because in here we will actually need to have another list of things. We basically need to have a list that says for function with this name, these are all the places in the machine code that need to refer to this virtual address that we will need to patch once we know virtual address. But I don't want to touch this yet because I want to flip them around, but that will be its own thing. So let's keep it for now. These things need to be U32 here and U32 here. Okay, that's good. Let's continue. Kernel32 RV. Okay, that's fine. Import directory index, import directory index. I think one of them is actually incorrect. This should be IAT directory, not import directory. So it's very interesting how did that executable actually work. But before I change this, I need to, let's continue with original refactoring. So we have this stuff here. And as you can see now, it starts to be very nice because this import descriptor just, it will be a serialized representation of some of the fields of our Kernel32 import internal data structure. Let's run tests. Okay, seems to be fine, but I'm still very confused why it works if this IAT directory is completely screwed up. So this should be this thing, I believe. Yeah. Maybe the loader doesn't actually look at it. That's interesting, I guess. But it also might be that why FileAlyzer was so unhappy with our executable and couldn't show imports because our address table was incorrect. So let's see. It is still very unhappy with the imports. Can Pepper show our imports? Okay. Pepper actually can show our imports, and they were previously missing. So yeah, this was a bit messed up. Good that we fixed this. Okay. That's nice. What is next? Well, next is image chunk array. That's exactly the same thing, where we now just say like this. Yeah. Let it fail, so it shows us where are the usages. We only have one usage, which is here. Let's retest. Everything is great. Let's continue. Okay. What do we need to do next? Well, next we have a list of functions. And it will be slightly tricky because of this stuff. So this will be wrong. But maybe we can add this to the list right away. I guess we need to. Or not. Okay, let's do a loop for now, and we say something like this. For U32 I is 0, I is less than Kernel32 function count. Actually, it is set to be S32 plus I. So what do we do for each of the functions? Well, we do this thing. We say this is RVA, and we can actually put it directly. We can say that functions I RVA is this stuff. Function name now will be part of the thing that's passed to us. So I'll actually copy the one that we use for DLL name. So here we say functions iname and functions iname. That sounds good to me. And we should not need this, but we use the ExitProcess name RVA in a couple of places. So let's figure out how to put it there. Well, in this thing, we just again need to do the same iteration. So we'll just have to iterate over this list like 3 times, but this is okay. And at the end of it, we still need to do the end of list stuff. So that's like this. But here it is much easier because the only thing we need to do is we need to output this RVA. So we do this and this. So this list just contains, again, offsets, relative virtual addresses of these data structure, which basically contains the name. Let's remove this stuff. This is a pretty simple loop. And then this stuff is pretty simple loop as well, which is exactly the same. So they both contain the same information. Now I wonder if we can merge these two. Like if they contain exactly the same information, can I just like point it to the same thing? And maybe I can, but for now I will try to follow the specification a bit closer rather than trying to extra optimize this stuff. Memcopy functions, yeah, that should be name. Okay, let's try this out. Okay, I screwed something up along the way. So what did I screw up? Well, I screwed up the ordinal hint. We need to put it first before outputting the name. Let's try again. And it works. Great, so we can clean up this stuff. Yeah, there is still this one patch that is a bit gnarly, but we will tackle it probably in the next video where we try to flip the sections. As the last thing for today's video, what I want to do is to just try to import a few more things and have them show up in Pepper, so we see that we actually correctly can output more than one thing into the executable. Now here I will add a machine code patch. I use these things to kind of link sections together. I learned this from videos of Johnson Blow, and I think it's a really nice way to go around the fact that languages don't really provide you a nice ability to link things. So now I have, I know that if I change this line, then I have to look in here and try to understand what's going on. So this is just a convenience thing. So I think there is something like get std out handle or something like this. Let's just go to msdn and find a few functions that we can load from the Kernel32. Okay, get a std handle, that seems fine. Is it from Kernel32? It is. Well, let's put it in here and let's do one more. read console sounds pretty nice. It's also part of, actually it should be read console A or read console V. Yeah. So let's do read console A. And what I want to see now is I want to see our executable not blow up. That's the first thing, so let's check that. It still works, everything is fine. And the next thing I want to see that if we open this executable here, we have 3 imports. Okay, that's great. So we have these 3 imports. Amazing. Let's do this. And maybe one final thing is having multiple of this stuff. So now I have to move this out into a type def. So let's do that. Type def struct. I accidentally removed stuff from my clipboard, which always is a bit tricky. Okay. So that's good. Import, that's one library that we have, and we will have multiple of those. Okay. Obviously, we now have a bunch of issues. So this is import library. That's fine. Let's retest. Everything still works. And now the tricky part. We need to iterate over all of them. So I want to have something like another array. For now, I'll just put it in a static array. Import library, import libraries is what? We put this into there. For now, that's enough. But now we can start iterating. So we say for S32 is 0, I is less than, actually, this probably needs to be U64. I is less than static array size of import libraries. Okay, this actually goes into here, so yeah. And let's call it Kernel32 Functions. Okay. So where do we go through them? Guess here we need to do this, and it will be a nested loop. We go through all of the libraries, and then we go through all of the functions in that library. So we say import library star lib is import libraries I, like so, and we say lib function count, lib functions. So all the Kernel32 stuff is going away. Let's see. Okay, till here everything seems to be fine. Next is a bit trickier because for now the order matters, but I guess it's still the same setup where we just go through all the libraries. and we say lib IAT_RVA is file offset. Okay, like so. We remove this thing. Again, this is a big fix me about ExitProcess because that should not be hard-coded. Maybe I will make it even more visible so we know that it's really bad what we're doing here. And now we can do this stuff. But instead of Kernel32 functions, we do lib functions. And lib functions over here. And end of a list. Okay. That looks good. IAT directory index. Well, I guess I'm not even sure if this is supposed to be pointing to this thing or not, but okay. So this needs to go into here, and we need to do it like this. Because we know the offset over here, but we only know the size at the very end of this stuff. Okay. Now we have exactly the same list here. We don't need to patch anything. And actually this is even more hacky than it was before, where we say if how do I do this? So it's not so horrible. Well, okay. If I is 0, yeah, this is a pretty bad page. I hope I got it right. But here we need to do image thunk RVA, and afterwards it's exactly the same loop. So this is good. And then we have library names. This is also pretty straightforward. We do again the same loop, but now we have lib DLL RV is this stuff, and then we just copy everything and we replace Kernel32 dots with lib arrow. Okay, good. What is problematic here? Yeah, it should be like this. Good, it's fine. And finally we need one more loop, and this is a loop that I'm least certain about. Let's just put it that way. Okay. Image import descriptor, and we do lib and lib. Okay, that builds. Let's see if I screwed something up. I did not, which is really nice. One final thing is for us to try to put another library. And that will be probably user32 DLL, because it's also used quite a bit. User32 functions, user32 DLL, and then we need some function that is correct, because I think it will explode if we try to give it something that does not work. So msdn user32 DLL. Is this part of user32? Great. So show window, that will be our guinea pig. And we need, damn it, I changed it instead of copying it, but it's fine. Kernel32 functions, Kernel32 functions. Okay, kernel has to be first because of our problem over here, but otherwise it shouldn't matter in which order we put these things into. So moment of truth, it works perfectly fine. And if we open it up and open it over here, we should see that now our import directory has two things. We have 3 functions loaded from Kernel32, and we have 1 function loaded from user32 DLL, which is great. This leaves us in a very good place to try to do this final swap around between the code and the R data segment, so that we can get rid of these patches, which would be amazing. And then we will be ready to start integrating with our machine code generation. And now that we set up all of these structures over here, we also know what they need to look like, right? We know how this behaves, which is really, really neat. For now, that will be all. I thank you very much for watching, and hopefully see you next time.